to do a very important part of electrochemistry. Okay. That is called Nernst equation. Yes, it does not write. What happened? Wait. It's called Nernst equation. Remember, when we have discussed the determination of standard electrode potential, or initially I have given you the example of galvanic cell. In that case, we have taken 1 molar solution of electrolyte. That is electrolyte concentration is 1 molar. And temperature was 298 Kelvin. See, whenever you are carrying out this experiment, every time the concentration of electrolyte may not be 1 molar. It may be less or it may be more. Moreover, the temperature also may not be 298 Kelvin. So in that case, we have deviated from our ideal condition. All right. Moreover, we have found that electrode potential is nothing but the potential difference between the metal and the metal ion. So the concentration of metal ion in the electrolyte also play a very vital role. So Nernst has incorporated both the standard electrode potential and the contribution of the concentration of electrolytes in a solution. That is known as Nernst equation. Okay, this note and everything I have given you earlier also. Please read the definition on Nernst equation. Why I am saying? Because in your book, interestingly, they have discussed the whole Nernst equation, but they did not give the definition of the Nernst equation. Why would it was necessary for Nernst to propose an equation? Because every time we do not carry out this cell reaction in an ideal condition by taking 1 molar solution or maintaining the temperature at 298 Kelvin. Right? So in that case, you will find Nernst gave a relationship between electrode potential and the concentration of electrolytic solution and is And the equation is known as, I will not write this equation, and the relationship is known as NERNS, Nernst equation. Please write down this. The definition is missing in most of the book. Okay. For a general electrode reaction, okay, Mn plus was take n moles of electrons to give you the metal. Okay. So what is the Nernst equation for this? The Nernst equation is E Mn plus M. See, I did not put a 0 because I did not maintain the standard condition. Equal to E0 Mn plus M minus RT NF ln MS divided by N plus aqueous. I have to put a concentration of both of them. So this is the Nernst equation. So let me write down what is the meaning of this. Okay, before that, see, this is exponential this logarithm, but in our all calculation, we are taking log 10 based. So we write now again here E Mn plus Ms. Okay, right here. And do it will change here. First you try to understand, then write Mn plus aqueous Ms. Mn plus aqueous Ms. Okay. So I'll now convert it. You know how to convert exponential base level log to log 10 base, or you can write E Mn plus aqueous Ms equal to E0 MN plus aqueous MS. So I have to multiply by 2.303 and F log so if this is equation 1, this is equation 2. Now what are the meaning of this? Let me write. Right now, where electric potential. This is this. This is, see, this is there. So right now, standard electric potential. Sorry, 2.303 R. Now what is R now? It is universal gas constant. Is equal to 8.314 joule Kelvin inverse mole inverse. T is 298 and is the number of moles of electron which varies from electrode to electrode. Some electrode may give 1 mole of electron, some may give 2 moles, some may give 3 moles. Okay. And what is F? F we know, charge carried by each mole is equal to 96,500 coulomb. Now what is MS? Concentration of electrode and MS Mn n plus aqueous is concentration of electrolyte, or you can write concentration of metal ions. substitute all the values in the equation 2. Okay, we'll write here now. Substituting the values of R, T, and F in equation 2, we get. So we'll get now here E Mn plus equals Ms is equal to Mn plus equals Ms 2.303 8.314 298 n into 96,500 log ms and log m plus equals. Is equal to E Mn plus equals Ms equal to E0 Mn plus equals Ms 0.059 by n log, we'll write this one, Ms and Mn plus equals this. So this is our equation 3. Yes. Okay. Now see, in class 11, we have studied about equilibrium. We have found when a chemical reaction attains equilibrium, any substance, if it exists in the form of pure liquid or pure solid, its concentration is always being considered as constant, or we write 1. Okay. At equilibrium, the concentration of any solid or of any pure solid or liquid is considered as unity or 1. Therefore, ms, series solid, is equal to 1. Therefore, equation 3 can be written as E. Okay, now here I'm not going to write here. Okay, I'll write here. Equals ms is equal to E0 mn plus equals ms minus 0.059 by n log 1 divided by mn plus equals. So this is our ultimate Nernst equation at a specific electrode. So we can write it for cathode and we can write for anode, and from there I can find out the EMF of the cell. Okay. So this is what this equation is for only one electron. Okay. So now we can write, if you want to find out the EMF of the cell at ordinary condition, not 290, neither at 1 molar concentration, we'll write it for cathode and we'll write for anode and we'll subtract anode from cathode, then we'll get the EMF of the cell. Okay. Now, say let us go for galvanic cell. What is galvanic cell? Typically, we have taken here zinc S, zinc 2 plus. Okay, concentration say it is C1. Copper 2 plus, it is concentration say it is C2, and this is this. So what will be the for cathode? So for cathode is what? No problem. We'll write now here E. I am not writing aqueous now. Cu is equal to Cu C2 minus Cu log 0.059 n log 1 by C2 plus. So if it is a numerical for C2 plus, I'll write the concentration is C2. Sorry, for copper plus I'll write C2. And for anode, it is E Zn2 plus Zn is equal to E0 Zn2 plus Zn 0.059 n log Zn2 plus. If it's a numerical for Zn2 plus, I'll write C1. Okay. Don't write. Now for EMF of the cell. EMF of the cell. So what is wrong? We know E is equal to, we'll write now here, E cathode minus E anode. So E cathode you know, E anode you know. All right, so we'll put it. So in that case, it will be E uh, 0 U2 plus U minus 0.059 by N log 1 Cu2 plus minus is E0 Zn2 plus Zn and 0.059 N by log Zn2 plus this. Okay. Right after this, then I will do. It's very easy. Don't have to, you don't get scared. You will not be asked to derive also. I'll show you the shortest technique. See, you get here E cell is equal to, see, you'll find this one will be subtracted from this one. Okay, I'll write it. I'll not go for such shortcut. It will be E0 Cu2 plus Cu E0 Zn2 plus Z. Okay. Then this one will be 0.059 N log Zn2 plus by Cu2 plus. Cool. This is nothing but E0 cell. We have already done it. In when you detect, found out this electrode potential. So therefore, what I'll write now here, E cell is equal to E0 cell minus 0.059 N log Zn2 plus Zn and Cu2 plus Cu. This I have done only specifically the galvanic cell that we have initially first time we have discussed. Okay. Now see, we have found in galvanic cell, it produced 1.1 volt. But those days, this Nash equation was not there. And whatever they determined, they have determined experimentally. So it is not wrong. See, you know why? The reason is that they have taken 1 molar concentration of zinc sulfate solution, 1 molar concentration of the copper sulfate solution. So this is 1 and this is 1. So log 1 is 0. So whole thing becomes 0. So whatever the value that you got is because of E0 cells. Okay, now see E0 cell for what? Copper is what? 0.035 volt. Minus zinc is minus 0.76 volt. Okay, so how much it comes? It comes to 1.1. See, this is become 0 for the galvanic equation. So in that galvanic cell, initially the galvanic or voltaic cell that you have discussed, these did not contribute anything. Because of that they could not understand. They have taken 1 molar. Okay, but you may not take 1 molar, it may be less or more. So for voltaic cell or galvanic cell, this has become 0. So whatever the value they have got, they thought this is the one. But actually, if you do not maintain 298 Kelvin, and if you do not maintain the standard condition, in that case, value will not be like that. Okay, but then I'll show you the easiest way to remember. So I'll write the equation of the galvanic cell. Okay, see here. That is this one. This is the cell. Then we'll write now here cell equation. In cell equation, what do you do? First, you write the reaction of anode. So it is ZnS. So it gives us Zn2 plus 2 electrons. This electron goes to cathode. Electron, which is not difficult. So it is Cu2 plus Cu. Okay. Plus 2 electrons, it gives you Cus. I'll add. Okay. So it is Zn S Cu2 plus aqueous gives you Zn2 plus aqueous and Cus. So this is that one is the reaction at equilibrium. After the equilibrium process, please remember, when you reach equilibrium, then cell does not produce further amount of electricity. So I have to consider this reaction at equilibrium. So now, in equilibrium, how should I write the equilibrium constant that you know in class 11? It's not at all difficult. So it is nothing but the product of the concentration of this divided by product of the concentration of this. So right now here, Zn2 plus Cus. I'm okay, I'll write aqueous. And here it is Zns and it is Cu2 plus aqueous. More. See, at equilibrium. Okay, at equilibrium. See, those who are solid, I have to take in consideration this as 1. This is also 1. So I'll what will write now? Zns Cus equal to 1. Therefore, K is equal to Zn2 plus aqueous and Cu2 plus aqueous. See, is it the same thing? Okay, so in your book they have given like this. When we studied, it was not like this. We are being told exact thing. To make it very simple in your book, they made a mistake. Because they did not give. Numericals are there. But they have only given this equation. Up to this much you have written, no? Hello?
Yes, sir. Yes, sir.
Then what should I write now? What is the Nernst equation then? The general Nernst equation is the Nernst equation of a cell reaction. Okay. In that case, what should I write here? I'll write it here. For this one, it is E cell is equal to E0 cell 0.059 n log Kc. See, this is the equilibrium constant. So I'll write here now. K. Okay, if I extend it further, I'll write a general equation. I'll write now. Yeah. A moles of A, B moles of B, give me C moles of C, and D moles of D. So K is equal to what? C to the power C, D to the power D, and A to the power A, and B to the power B. Therefore, E cell is equal to E0 cell 0.059 n log Kc. So I'll put Kc here, finish. I'll show you what is the difference between this the equation that I initially have written and what is the advantage of writing this one. You'll never make a mistake in your life.
Sir.
Done. Okay. So now I'm going to explain it through two numericals. I just see here. That n that I have written now, n is nothing but the number of moles. So in this equation, n is equal to 2. So we write now here, calculate the EMF of the following cells. I'll write here 1. Zn S Zn2 plus 0.1 molar Cu2 plus 0.01 molar and Cu. This is 1. And B. We write now here CUS Cu2 plus 0.01 molar and Ag plus 0.001 molar and A. Okay. So what is your what is the first duty you have to do? A. So our first duty is to write the cell reaction. Cell reaction first you have to write a note. I'll write down here A.
Excuse me, sir. So what's that? Calculate the EMF of the.
Calculate the EMF of the following cells.
Okay, sir. Thank you, sir.
So I'll write here now that you become Ustad Palak. I do not write equals, forget. 2 electron and U2 plus 2 electron gives you US. Add. See, why do I have to require this writing equation? Because this is the one gives me the value of n, because it is minus 0.059 by n. That small n is nothing but 2 here. So we'll write now here, this is called overall rate. Overall is write together. So what will be the Nernst equation? What is the E? E is equal to E0. So one thing I forgot to give it there, huh? So I'll just change it, huh? Please don't mind, don't get angry with me. This is the problem of old age. We have to write here now, where E0 Zn2 plus Zn is equal to minus 0.76 volt and E0 Cu2 plus Cu is equal to 0.34 volt. See, minus is not the business, plus. And here I'll write B C US Cu2 0.01 molar. This is Kg plus 0.001 molar AgS. Right now, where this to proper to E0 Cu2 plus Cu is equal to 0.34 volt and E0 Ag plus Ag is equal to 0.80 volt. Very sorry, I forgot to write. Huh? Okay, you're right. Then after that, I'll do. So first we'll write the main equation. Then after that, we'll do stepwise. Huh? So E cell is equal to E0 cell. Then 0.059 n log Kc. So what is Kc? So Kc is equal to what? Kc is equal to, see, this versus this. So right now here Zn2 plus and Cu2 plus. And second, what is the value of n? See here, 2 moles. Okay, so this we know, now this we know. Then you have to find E0 cell. E0 cell. E0 cell is equal to E0 cathode minus E0. Now, how will you know which is cathode and anode? Very easy. Left hand side is anode. See, this is anode. This is cathode. This is anode. This is cathode. So, anyway, but initially I will not go in a hurry. Na? So, here cathode is what? Cathode is Cu2 plus U minus E0 Zn2 plus Z is equal to that value to this is 0.34 volt minus 0.76 volt, so is equal to 1.1 volt. Okay, so I'll put this now value here. So here E cell is equal to E0 cell is 1.1 volt. I need to write. Now 0.059 and value of N is equal to 2. See here, what is the concentration of Zn2 plus? No, 0.1. So 0.1, and this is what? So 0.01. Okay. So what should I write now here? See, this you can calculate separately. Log 0.1 and 0.001 is equal to log 10 to the power minus 1, 10 to the power minus 2. So it will be what? When it goes up?
So in the denominator is 0.01.
Huh? Wonderful boy, very nice, thank you. Is it not log 10? So log 10 is what? 1 or not? Huh? So it is 1.1, 0.059 divided by 2. Finish. This is log 1 only. Okay, you can write log 10. So now find the value. Plug. Rest I will not do. Two point 2.2 volts, huh? If I meet you right now, I'm going to break your head into few pieces, man. 1.1 minus this becomes 2.2.
0.8.
0.8. Who told 2.2? Who is that species?
Wait, so I made a mistake. 1.07.
Balai?
I don't know anymore. 1.1 minus 0.059 by 2 is 1.07.
Well, yeah. I'll do. 0.059 by 2. Tama no? Una 0. Una no? 2. Una no? 19. Huh? So it is 19 tama no? 9. So you subtract this one from this, how much it comes? Huh?
That's what I get.
So how much it comes? 1, una 7.
1.07 can
Hey, case of subtraction. This has gone, na? So borrowed no, it becomes 0 or not?
So wouldn't it be wouldn't we have to multiply by 2 at 1.1?
Why you have to multiply by 2? See, this is log 1. So no, you find out this value, then this value you subtract from this.
Yes, sir, that one.
I'm going to recommend your name for Nobel Prize in Mathematics for Meghalaya. Okay, okay, now we'll go for second. Okay. Now it is B. Okay. B. So what you are supposed to write? Do first you have to do always cell reaction. See here, which is anode and which is cathode. First you have to write the anode. This. So we'll write now here. Cell. So anode. It is CuS. It will give you Cu2 plus and 2 electron. Cathode. It is Ag plus. Second, this is Ag plus, so it is going to take 1 electron. So you will get here Ag. Please remember, any type of chemical reaction is electrically neutral. So what should I, how to make neutral now? Okay, then in that case I have to multiply it by 2. 2 electron given, 2 electron taken. So what is the overall reaction now? Overall reaction is CuS plus 2Ag plus gives you 2Ags and Cu2 plus. See, this is 1, this is 1. What is the value of Kc now here? Kc is equal to this Cu2 plus and see, remember our equilibrium, this coefficient is raised to the power. Because of that, you always, I told you, write Kc. If you follow book, 1 Kc. And what is the value of N here? N is equal to 2 moles. So what is this Nernst equation? Nernst equation is E cell is equal to E0 cell minus 0.059 by N and log Kc. We'll put the value here, Kc now. So we'll write now here E cell. I'll expand this one more. So I'll write it this. It is E0 cathode minus anode. What is the cathode here? Silver. This. E0 Cu2 plus Cu and minus 0.059 N. What is the value of Kc here? Log C. Cu2 plus and Ag plus square. So now you put the value. This is 0.001 molar and this is 0.001 molar. Put the value. These values are given here. Find it. This is very, very important for MBOS. I'm telling you. 100% chance is going to come next year. And as well as for your CBSE. This one.
Wait. It's 0.0.
Log. I'll write 0.01 and 0.001 square more. So I can write this one log 10 to the power minus 2 and you have squared, na? How much it comes? 10 to the power minus 3 square. How much it comes?
log
It will be log 10 to the power minus 5 on, it will go, na? Ultimately, you will get what? It will be what? Is it not log 10 to the power 4? So log 10 to the power 4 is equal to what? Log 10, no? Log 10 is equal to what? 4 or not?
Hmm.
Huh?
Yes,
Say
sir.
something. Are you very good? At least somehow you agreed with me. So now do. Acha, what about Miss Aditi is there?
Yes,
Huh?
sir.
Acha. Then Aparajita is there.
Yes, sir.
Then what about Miss Rao? Maybe she's sleeping. Acha, could anyone locate Shubhankar Shah? He has gone home. After that, I don't know what he is doing. And this Abhinav from Anthony's, I think, na, he's almost one meeting. I at least 1.5 month I did not see a single post. Not a single day. Is both Shubhankar Shah and this is, I think, Abhinav, I think. I don't know that they're still in the group or not. But anyway. So please
0.3.
always do the numerical in this way. In your book, they have given directly, they have given this. So if it is like this, if you follow book, then what will you write? Cu2 plus divided by Ag plus. So actually it is square. You can get it only when you find the equilibrium constant of the reaction. All right?
Yes, sir.
Yes, sir.
Okay. Acha, I think I did not send you this question.